Hey, welcome to the Explainer. Today we're going to break down a pattern that's a real lifesaver. You know that code that gets super messy and hard to manage? Well, we're talking about the strategy design pattern, and it's here to turn that mess into something, well, elegant and flexible. Okay, so here's how we're going to do this. First, we'll look at a problem that I bet you've seen a million times. Then, we'll bring in the hero of the day, the strategy pattern. We'll see what it's made of, check it out in the wild with a real example, and yeah, we'll talk about the good and the bad. Stick around because it all boils down to one big idea that could totally change how you write code.
All right, let's dive right in. First things first, let's talk about that code. You know the kind. The stuff that gives us all a major headache. It always starts out so innocent, right? But then before you know it, it's a complete nightmare to maintain.
I mean, does your code ever end up looking something like this? As your app gets bigger, you just keep adding more and more conditional logic. And what started as a simple if statement suddenly spirals completely out of control. And yep, this probably looks familiar. It's that giant switch statement, or a massive chain of if-else blocks. Every single time a new requirement comes in, hey, can we add a new payment option? You've got to go back and mess with this one monster of a file. It's brittle, it's a total pain to test, and good luck trying to figure it out 6 months from now. So that's the problem, right? The big mess. But what's the fix? Well, thankfully, there is a much, much cleaner way to do this. And that's where the strategy pattern comes into play. So what is it exactly? Well, some people call it the policy pattern, but the idea is just elegant. Instead of cramming all your logic into one spot, you create a whole family of different algorithms. And here's the kicker, you make them totally interchangeable. You can swap them in and out. What that means is the core part of your program can get new behaviors without you ever having to change its code. You know, the original Gang of Four book on design patterns really nailed it with this quote. It's all about defining that family of algorithms, wrapping each one up on its own, and making them swappable. That's the heart of it, right there. Okay, so encapsulation, interchangeability, those are great buzzwords. But what does it actually look like? To really get it, we've got to pop the hood and look at the three main parts that make this whole thing tick. It's actually pretty simple. You've got three main players. First, there's the context. Think of this as the main object, like our shopping cart. It's the thing that needs a certain behavior. Then you have the strategy interface. This is basically a contract, a set of rules that all your different algorithms have to follow. And finally, you have the concrete strategies. These are the actual workers, the individual classes that do the job, one for credit card payments, another for PayPal, and so on.
Let's try an analogy to make this super clear. Think about planning a trip. You are the context. You just need to get from point A to point B. Now, how you get there, whether you drive your car, take the bus, or just walk, that's your strategy. And you decide which one to use right when you need it, based on the weather or how bad the traffic is.
And check this out. This is where it all snaps into place. See how perfectly that analogy maps to our code example? The traveler, that's you, is the context, just like the shopping cart. The general idea of a travel method is our payment strategy interface. And then the specific choices, like driving a car or taking a bus, those are our concrete strategies, just like paying by credit card or paying with PayPal. It's the exact same structure. Okay, I think the analogy helps a lot. So now let's see how this plays out in a real-world app. Let's bring that payment system example to life and see the code in action. So, in our e-commerce app, we're going to ditch that awful switch statement. First, we define a common interface. Let's call it payment strategy. Then, we make separate classes for each payment type. A credit card payment class, a PayPal payment class, you get the idea. Now, our shopping cart doesn't care how the payment is made. It just holds on to one of these strategy objects and says, hey, go process the payment. It delegates the whole job. And this pattern isn't just for brand new projects. It's an amazing tool for refactoring old, crusty code. There's this great story from a developer, Tracy Lum. She had this really rigid script that was a pain to change. So what did she do? She used the strategy pattern to pull out each different operation into its own interchangeable strategy. And the result was amazing. Now, adding a new feature is as easy as creating a new class. No more messing with that fragile core logic. Okay, but let's be real. As powerful as this pattern is, it's not a silver bullet. It's not the perfect tool for every single situation. Like anything in software, there are trade-offs. So let's take a minute to look at both sides of the coin.
So on the one hand, the pros are huge. You get incredible flexibility. Your code follows the open-close principle, which is a fancy way of saying you can add new stuff without breaking the old stuff. It keeps your concerns separate, and it makes testing way, way easier. But on the other hand, there's a definite drawback. You can end up with a lot more classes and files in your project, what some people call a class explosion. And honestly, if you have a really simple problem that's never going to change, this pattern is probably just overkill.
So we've been through a lot. The problem, the solution, the pros and cons. But if you're going to walk away with just one thing, what should it be? What's the core idea here? It really all boils down to this. The strategy pattern lets you separate the what from the how. Think about it. Your shopping cart knows what it needs to do. It needs to process a payment. But it doesn't care about the nitty-gritty details of how. It just hands that job off to a specialized strategy object that knows exactly how to handle it. So that leaves me with one final question for you. Think about the code you're working on right now. Where do you have one of those big if-else blocks or a switch statement that's just deciding which chunk of code to run? Because that right there is a giant flashing sign. It's telling you there's a hidden strategy just waiting to be pulled out, ready to make your code way more flexible, so much easier to maintain, and ready for whatever comes next.